So for this problem, we want to prove that the limit of x approaches 4 of 4x minus 15 equals to 1 using the precise definition of a limit. So for step 1, we want to find delta. So in this case, we have a equals to 4 and L equals to 1. We're going to assume that epsilon is greater than 0. So we're going to use the fact that 4x minus 15 minus 1 is less than epsilon. So now we're going to simplify what's inside. So we're going to get 4x minus 15 minus 1 less than epsilon. So we're going to get 4x minus 16 less than epsilon. We can factor out a common factor of 4, leaving us with x minus 4 less than epsilon. Now we're going to divide both sides by 4. So we get x minus 4 is less than epsilon over 4. So this implies that there's a relationship between delta and epsilon, which is delta equals to epsilon over 4. Now step 2 is where we actually write out the proof. So we're going to let epsilon as greater than 0. We're going to assume that 0 is less than x minus 4, which is less than epsilon over 4. So this can also be written as 4x minus 15 minus 1 is equals to 4x minus 16, which is 4 as a common factor, so it's left with x minus 4. But we know that this right here is delta, which is also epsilon over 4. Therefore, we can write this as being less than 4 times epsilon over 4, which is simply epsilon. Therefore, we have shown that for any epsilon greater than 0, we have f of x minus L equals to 4x minus 15 minus 1, which is less than epsilon whenever 0 is less than x minus 4 less than delta. Therefore, we have 0 less than delta less than equals to epsilon by 4 as a condition for this. Therefore, the limit of x approaches 4 of 4x minus 15 equals 1. Now, as a check, we simply plug in the value of x into the equation. So we get 4 times 4 minus 15, which is equals to 16 minus 15, which is 1. Hence proved.